So if Adam can move a large yard in 3 hours and Matthew can move the same yard in 5 hours, working together, how long will it take for the two boys to move the complete yard? So there are a couple approaches I will provide you, and you can actually see which is more intuitive and easy to you to understand, and you can use that one to solve. First we will use a graphical approach so that we can understand what we are trying to really do. So I'm going to draw the yard here. Just say that this is a yard, and since Adam is going to move in 3 hours, so let me split this yard into 3 equal pieces. Actually we'll make it a little bit more equal, so which means that in 1 hour Adam is going to move 1/3 of the yard. Similarly, when we draw for Matthew, the yard length is going to be the same, so let's keep the box same size and split it into 5 pieces now in this fashion, and then say since it takes 5 hours, that means he is able to move only lesser amount of yard, and we can see that in 1 hour he moves 1/5 because it is divided into 5 equal pieces. So Adam moves 1/3, and so that means Adam can work faster than Matthew. That is very clear from this one. Now working together means if I have to add them, that means in 1 hour, because remember the diagram shows what can be moved in 1 hour. So if they work together, what will happen is in 1 hour we will say Adam plus Matthew, they will be able to move 1/3 plus 1/5. Adding these two shaded fractions gives us 8/15. So what does this mean is that in 1 hour 8/15 of the yard is moved. So now we need to find out how much time, which we let it be x, they can move to do the complete yard. A complete yard is always out of a whole or a unity 1. So let us solve these proportions, saying that x/1 is 1/8/15, which is 15/8, and this is let's multiply by 60 because we are asking in minutes, and we get 225. You divide by 4 both sides, so we can do this is 2 and this is 15, so we get 225/2, which is 112.5. so many minutes is what it takes. So this is less than 2 hours. So answer is B. So actually you can realize that when we have 1/3 and 1/5, actually we could have drawn here if you wanted to. The 8/15 could also be drawn. This is the combined. That means if I were to divide this into 15 pieces like this, so assume that this is 15 pieces, even though it may not be an exact count, and we have done 8 because 8/15 can be represented as like this. That means this is 8/15, and this is the amount it takes to move in 1 hour. So you can see that the remaining yard is 7/15, so it has to be little less than 1 hour, which means about little less than 2 hours. So if you don't want to solve exactly, you can still come closer to the estimates that B is closer because it is less than 2 hours. C is a little over 2 hours, which means that C cannot be the answer because that is the only next closest tie to this solution, and without even solving you can select the answer B. But we have already gone and shown if you were to exactly calculate how much it would take, you can get 112.5 minutes. So this is a graphical approach of solving this problem, but we will also provide a different way, because in an exam you may not have all this luxury of thinking and drawing all this graphical approach, so you have to be a little faster. So we will try to provide a different approach and then see if that helps you to be able to do over this method. So let us try to do this problem in a different way. So let us make some space here, erase the old technique, and Let's change the ink here now. So there is another concept called distance, which you may have heard about it. Distance is speed into time. So actually some people also narrate these problems as work, because you are doing some work, and speed is power. That means how fast are you able to do. So these are two different ways you can think, but I will use the first way because it is much easy to correlate these terms. So I will say distance is same as how much yard to move. Speed is how fast, that means how fast you can move the yard, how fast, and time is the amount of time it takes to move. So let us try to see Adam. For Adam the speed will be, so I can say Adam is moving the yard, distance will be 1 because the entire yard will be out of a hole, and let Adam's speed be a, and he takes 3 hours, so we will say 3. So that means Adam's speed is 1 by 3. Now Matthew is also, his distance or the amount of work he has to move is 1, but his, let us call this as m, his speed, and he takes 5 hours, so we will put it as 5. So we get Matthew's speed is 1/5. So what we are seeing here is Adam is faster because 1/3 is greater than 1 by 5 and his speed is faster. So working together, I will simply say the yard length is not going to change because they are going to still move the same yard. So I will call working together. So let us call this as together, or let us change this ink and right. So we will call together, the yard length will be 1. The speed is however a plus m because now they are working together and we don't know the time t. So what we can do is we simply add the speeds we got, 1 by 3 and 1 by 5. So this is t. Now we can solve this t equal to, we have to flip the fractions, so it will be 15/8. So we still get the same answer as we got previously. So this is an algebraic way of doing the same problem for this one. So let us recap that in an algebraic way. What we are saying is the amount of yard that you have to move is something like a distance. Speed is how fast you can move, and time is the amount of time it takes to move the yard. So now what we did is we calculated the speed for Adam, how fast he can move. For Matthew also we calculated, and then we added together the two speeds to find out how much time it takes.